In this video, I'm going to explain the results of the random rectangles activity. First, you need to perform a judgment sample by picking any 5 rectangles. I tried to pick some small and some larger rectangles. For example, I started with rectangle 21 that has an area of 1 and filled it in my table. Then I picked rectangle 15, counted up the area, the number of squares there. It had 9 squares. I did this with 5 different rectangles and then finally found the average of my areas. For step 2, you need to take a random sample. I started by doing the ran_between function to select a number between 1 and 100. That gives me an ID number for the rectangle. For example, the first rectangle selected is number 27, so I recorded the area for that rectangle, 1, 2, 3, 4 squares. I repeated this process with the ran_between function 5 times to select 5 random rectangles. Finally, I find the average of my randomized areas. Once you have these 2 averages and your answers, you are going to go to the Google spreadsheet and add them into the spreadsheet. Find a blank area, like for example right here, my average for the selection was 9.6 and for randomization was 9.4. So I'll put those in, 9.6, 9.4. Then the averages will automatically update for everybody in the class. What this activity is meant to show you and why I wanted you to participate in it is when you select the rectangles yourself, you think that you're getting a little bit of everything. Some of the small rectangles and some of the bigger rectangles like this one. The problem is that your brain automatically overestimates how many big ones there are and underestimates how many small 1 square rectangles there are. You tend to miss the smaller pieces. However, when you do a random sample, each rectangle has the same chance of being included, so your brain isn't over or underestimating which rectangles are present, allowing you to get a sample that's actually more representative of all rectangles on the page. Of course, some random samples will have a higher average area than others, but when we put our data together for the whole class, some of these averages are higher, whereas some are lower, and overall they get closer to the real average. If you take the average area of all 100 rectangles on the page, it's actually 7.42. The random average is much closer to that value at about 7.3 than our selection average, which is about 14.3 and much higher. This is because, as I mentioned, your brain will automatically move towards those larger area rectangles whether you mean to do this or not. This is the reason why you should never do a judgment sample. For example, if I wanted to survey students at Cambrian College, I might think I could do a really good sample by picking some students from every program, students from different countries all over the world that come to Cambrian. I could try to choose some students that are in different age ranges, like right out of high school or more mature students. But you're actually going to get better coverage of all the different possible students at Cambrian just by randomly selecting students from the overall student population. That way you'll get a little bit of students from all over and with various characteristics that you wouldn't even be able to account for if you tried to list all the possible characteristics and choose somebody with each of those characteristics. So randomization is actually the best way for you to get a representative sample from the population because it covers you against those characteristics that you don't even know about by automatically giving every person the same chance of being included and making your samples overall actually look more similar to the overall population we started with. How this example shows this is our random average is a lot closer to the real population average than when we tried to choose with our judgment.